All right, so we're going to end our lesson with taking what we've learned about the sums of interior and exterior angles and using that to figure out what if we wanted to know what just one interior angle was. We're going to bring in this idea of a regular polygon. So a regular polygon is a polygon in which all sides and all angles are congruent. So every side length is the same and every angle measure is the same. So example 6, find the measure or number of sides given one exterior angle. So the measure of one exterior angle, well, we know that the sum of the exterior angles is 360 degrees. So the measure of one angle is we would take that 360 and divide by our number of sides. A number of sides is also the same number of angles that we have. Okay, so part A, find the measure of one exterior angle of a regular dodecagon. So dodecagon is a 12-sided polygon, so n equals 12. We're just going to use our formula we just learned about. One exterior angle is equal to the sum, 360, divide it down by how many there are. If there's 12 sides, there are also 12 angles, and we get 30 degrees. So one exterior angle in a regular, by the way, this only works if this was a regular polygon. One exterior angle is equal to 30 degrees. Every exterior angle is equal to 30 degrees. We just found the measure of a single one. All right, part B, the measure of one exterior angle of a regular polygon is 36 degrees. How many sides does the polygon have? When they ask for how many sides, you have to find n. So we're going to be using an equation and solving for n. Because they gave us one exterior angle, let's use our exterior angle formula. One exterior angle is equal to 360 degrees divided by n. And they told us one exterior angle is 36, so that is our E. So we're just going to plug in a 36 for one exterior angle. 36 equals 360 divided by n. Now to solve for n, the problem here is it's in the denominator of a fraction. So let's just multiply both sides by n. That's just going to get us out of that fraction. I'm going to rewrite this over here. I should have given more space. Hopefully you guys are writing smaller than me. 36n equals 360. And then let's divide both sides by 36 to solve for n. Something to keep in mind when you guys are solving for number of sides, if you're trying to find the number of sides, decimal answers are not possible. So I can't have 4.7 sides of a polygon. I can have 4 sides or 5 sides. So if I do this math and I take 360 divided by 36 and it doesn't divide perfectly, I have made a mistake somewhere if I'm trying to find the number of sides. Decimals are okay for angle measures. We had a problem earlier in this lesson where we had like a 67.5 degree angle. Angle measures can have decimals, that's totally okay. Number of sides, no decimals. So maybe make a side note in your notes for that. Hopefully you guys have the volume on and you are listening. All right, so if we divide that, we get 10. So this polygon has 10 sides. And if they asked us what polygon it was, we could say that's a decagon. Decagons have 5 sides. 10 sides is what I meant to say. All right, so our last example, we're going to find the measure of one interior angle of a nonagon. A nonagon is a 9-sided polygon, so n equals 9. Right up here in this box above, we've got 2 options for how to do this. You can find one interior angle by using the interior angle sum, or we can use option 2, where we find it using the one exterior angle. So what we're trying to figure out is one interior angle. So if we use option 1, what this is saying is take the sum of your interior angles and divide it by how many sides there are, which corresponds to how many angles there are, and that's how you'll get your one interior angle. So this sum of your interior angles, just a reminder, is that 180 times n minus 2. And if we divide that down by n, that will tell us what one interior angle is. So let's go ahead and work out option 1. Our interior angle is equal to the sum of our interior angles divided by how many sides there are. So we're going to do 180 times 9 minus 2 divided by 9. 9 minus 2 is 7. Divide that by 9. And we get 140 degrees for one interior angle. All right, so how does option 2 work? And maybe you'll be like, oh, well, I like option 2 better. Or maybe you guys will like option 1 better. So option 2 says, let me just kind of draw us a little figure just to remind you. Let's pretend this is a regular polygon. We'll pretend all these angles and sides are congruent. All right, there's my little congruency marks. So they're saying if you need one of these interior angles, why don't you take the extension? So take the exterior angle right there, if you know that. So you can take 180 minus the exterior angle to get the interior angle, because those are supplementary. So our interior angle is equal to 180 minus our exterior, which has that 360 divided by n. So that's what we're looking at option 2, and that's where it comes from, is we know that an interior angle and the exterior angle will add up to 180 degrees. So if we need the interior, let's take 180 minus the exterior. Sounds like fun. All right, so option 2, our interior angle is 180 minus the exterior angle. And our exterior angle is found by taking 360 divided by n. Actually, why don't we just fill in our n right now? We know that we have 9 sides. 360 divided by 9 is 40. And 180 divided by, or minus 40 is 140 degrees. So you can see we're getting the exact same answer, just 2 different approaches. So you can kind of pick your favorite and run with that one.